You the IM3-6-3 extra practice number 5 solutions on adding and subtracting rational expressions. There's a puzzle that goes with this one. Let's see what that's all about. So here's the puzzle that goes along with that extra practice. We're trying to solve the riddle, why isn't a snowman very smart? And to solve this, we have to simplify these 10 expressions that they've given us here. Now the way this is set up, the first 5 expressions, the answers for those are down in the lower left. The answers for the other ones are down in the lower right. So once you solve one of these and pick the letter that goes with the answer that you just got, you just have to put that letter down in one of these boxes below. And the box just corresponds with the number of whatever problem you just did. So let's say I do problem 1 and I get choice A. I don't know if that's it, probably not. But if that were the answer, I would put an A in spot number 1, and so on and so forth for the rest of these until we filled all of them in. All right, so let's see what this holds in store for us. So here we go with problem number 1. Now in this one, I'm going to introduce a few strategies that I'm going to use in most of these problems. One strategy is going to be to factor things out in the very beginning so that I can more easily find my least common denominator, my LCD, which I need if I'm going to be able to combine these together. Next strategy I'm also going to use is whenever I have a minus fraction, I'm actually going to rewrite that as a plus and then distribute the negative to whatever's in the numerator of the fraction that I'm adding. So we'll do both of them here. For my first fraction now, x squared minus 4, I can definitely split that up using a square root shortcut. That's the plus minus one. So we have the square root of x squared, which is x. Square root of 4 is 2. So x plus 2 and x minus 2. Next up, I'm going to rewrite this next one as a plus negative 3 over x minus 2. Not a huge change, but again, I like to take care of that negative early on so I don't forget to distribute it later. Now I need to find my LCD. So taking a look at my first denominator, we've got an x plus 2 and an x minus 2, so definitely need at least that. And then looking at the other denominator, we have another x minus 2, which is already covered by this x minus 2 I wrote earlier. So to move forward with this problem, I don't really need to do anything to my first fraction. That one already has the LCD. The second fraction, however, we're missing the x plus 2. Now, if you have trouble finding LCD multipliers, one trick you can use to see what you need to multiply by is just to divide the LCD by whatever you already have in the denominator, and then whatever you get, that's what you need to multiply by. So in this case, if I divide this whole LCD by x minus 2, that would cancel these x minus 2's, leaving me with an x plus 2. So if I multiply by x plus 2 over itself, I'm really just multiplying by 1 here. This will help me get the LCD. So rewriting things, we have the 8 over the LCD. Now negative 3 is getting distributed. And notice how I put parentheses when I multiplied by this x plus 2. I didn't have to do that because they're kind of built into fractions, but that helps me remember to distribute later on. So negative 3 times x, that's negative 3x. And then we have negative 3 times 2, that's negative 6. And then I have the LCD, x plus 2, x minus 2 downstairs. So when I add these together, now that I have the same denominator, I end up with that common denominator. And now I have an 8 plus a negative 6, which is going to give me a 2. Negative 3x is just along for the ride, so negative 3x plus 2. Final answer. And actually, let me double check. So sometimes you can factor and reduce at the end of these problems. This one, it doesn't look like we can. So I'm going to just see if I can find that. It's right here, choice O. So that's going in spot number 1. And just checking real quick, because some of these have more than one that they go in. That's the only one, though. So it's on to the next problem. Here we go with problem number 2. Just like before, I am going to factor everything I can in the denominators at least. So first denominator, numbers that multiply to negative 15 and add up to negative 2. That would be, let's see, 1 and 15 doesn't work. 3 and 5 works. Positive 3, negative 5. So x plus 3, x minus 5. And my other fraction can't be factored. However, since I have a minus here, I'm going to write plus and then a negative 2 just to keep track of that negative sign a little more easily. All right, moving on now. Let me find my LCD. my first denominator, that whole thing, x plus 3, x minus 5, needs to go in the LCD. And then the next denominator has an x plus 3, but that's nothing I haven't already seen before. So this LCD covers the second fraction as well. So moving on then, we have to rewrite that first fraction. And now the second fraction, what am I multiplying this by, since I don't have the LCD yet? Well, dividing the LCD by this denominator would cancel the x plus 3's. So that means I need to multiply by an x minus 5 over itself to complete that LCD. So I've got my first fraction again, no change there, because it already has the LCD. Second fraction, let me now multiply my numerator together. Negative 2 times x is negative 2x. Negative 2 times negative 5 gives me a positive 10. And then I have that LCD in the denominator there. Now that I have the LCD, I can have one big denominator for both fractions, and now I can just add the numerators. This negative 2x has nothing to combine with, so it sticks around. 9 plus 10 gives me 19, so negative 2x plus 19. And taking a close look at this, it doesn't look like I can factor negative 2x plus 19 at all, so I've already got the answer then. And where am I going to find that? Right here, next to choice A. So I'm putting that in spot number 2 right here. But there's also another 2 over at the end here, so I get to use that one twice. For this next problem, let me start by factoring that lower left denominator. So things that multiply to 14 and add up to negative 9, that would be not 1 and 14. Negative 2 and negative 7 would do it. So x minus 2, x minus 7 for that. And then let me rewrite the second fraction as a plus negative 4 over x minus 7, just to make that a little bit easier. So for LCDs, my first denominator, I've got an LCD with everything in that first denominator, x minus 2, x minus 7. That also covers the x minus 7 in my second denominator, so this is the whole LCD. Now I'm going to rewrite this so I'm multiplying my second fraction by whatever it needs to get the LCD. First fraction is good the way it is. It already has the LCD. Second fraction, we're missing this x minus 2. So let me multiply by x minus 2 over itself. So first fraction, still unchanged. Second fraction now, distributing that negative 4 up there. That's negative 4x plus 8 all over the LCD. And let me keep my LCD for one big fraction now. Just combine the numerators. 7x plus negative 4x is going to give me 3x, and then that 8 is still going to be there. Can't factor anything out of 3x plus 8, so I just look for this in the answer choices. It's right here, it's E. So I'll put that next to the 3 here, and it looks like that's the only 3, so on to the next. The last 3 problems have been pretty similar. This one has a lot of similarities, but breaks the mold a little bit, in that the first fraction's denominator now cannot be factored, but the second one can. So I'm going to leave this 3 over x minus 4 as is for now. For the next one, I'm going to do 2 things. One thing I want to do is take care of this negative fraction, so I'm actually going to distribute that negative to the numerator right away and write this as a plus fraction. So we'll write plus and then negative x minus minus gives me a positive 9. So now I don't have to worry about doing that later. And I'm also going to factor my denominator. X squared minus 16, I can split that up into x plus 4 using my square root shortcut there, and x minus 4. For my LCD, I definitely need whatever's in this bigger denominator, so x plus 4 and x minus 4. And that also covers this small denominator that only had the x minus 4 in it. So now going back and multiplying by my fancy form of 1, first fraction is missing the x plus 4 in the denominator, so let me multiply by x plus 4 over itself there. And then the second fraction already has the LCD, so no change needed just yet. Going back to the first fraction, let me distribute that 3. So that's going to be 3x plus 12, and my LCD is what I get in the denominator there. Second fraction, no change needed just yet. At this point, since we have the same denominator, I'm going to add those together and keep my denominator. And now for the numerator, combining like terms, we have a 3x plus negative x, that's 2x, and 12 plus 9 gives me 21. 2x plus 21 cannot be factored any further, so I'm going to call this good and look for it in the answer choices. I see W right here is a match, so let me stick a W in box number 4. For this next problem, the setup is kind of similar to the last question, but there is one small difference at the end that we'll see. It's an important one. For now, though, first fraction we can leave the same. Second fraction, I can fix two things about this. First off, I'm going to make this minus into a plus, and then distribute the negative to the numerator, so negative 2x minus 5. Now I won't forget to do that later on. And now my denominator can also be factored. Things that multiply to 20 and add up to 9. 1 and 20 doesn't work, 2 and 10 doesn't work. 4 and 5 works if they're both positive, so x plus 4, x plus 5. And my LCD then is going to have the x plus 4 and the x plus 5 from that bigger denominator. And that also covers this x plus 5 over here. So let's go ahead and multiply by whatever I need to get this LCD. First fraction, we're still missing the x plus 4, so let me multiply by that over itself. And then second fraction, we already have the LCD, so we'll just leave that the way it is. First fraction again, let's distribute that 5 to multiply those numerators. So we have 5x plus 20. Denominator is going to be our LCD of x plus 4, x plus 5. Next fraction stays the same, no changes yet. But now, since I have the same denominator, I can get one big fraction over that common denominator and add the numerators together. Combining like terms up here, we have 5x plus negative 2x, that's 3x. 20 plus negative 5 is 15. And take a look at this. I'm glad I checked, because we can factor the numerator a little bit. Common factor of 3 can come out of both of those. So denominator will stay the same for a little while. Taking a 3 out of that numerator, we have an x plus 5. Cancel out those x plus 5s, and we end up with a 3 over x plus 4. So that matches choice I right here, and that's going to go in spot number 5. So we have one of those going over here, and even though that was a fair amount of work, we only get to use it once. It's on to the next. So problem 6 is the first in the second set of 5. So we have a different set of answers over here. Notice now that we have D's instead of whatever other letter we were dealing with before. And also, this is a little bit different as well, because we don't have any factoring to do at the very beginning. These are as factored as they're going to get. So we can go straight to looking for the LCD. So the LCD at minimum needs to have a D minus 7 in it. And it also needs to have this other denominator of 3D plus 1. So now multiplying each of these by whatever it's missing, the first fraction is missing the 3D plus 1. Second fraction will multiply by the D minus 7 because it was missing that. And I'm also going to make this a plus negative 2 right there, just so I'm not worrying about doing that later. All right, let's go ahead and multiply things out. So in my first fraction, distributing that 3, we've got 9D plus 3. And then the LCD down here has both of those factors. Next fraction, we're distributing the negative 2. So that's negative 2D and then plus 14 there, all over the LCD. So we have a common denominator of a D minus 7 and 3D plus 1. Adding the numerators now, we have 9D plus negative 2D, that's 7D. 3 plus 14 gives me 17. And although I've got lots of 7s, there's no actual common factors between those two in the numerator. So this problem is as good as it's going to get. And I see that answer right over here. That's answer H. So that's going in spot 6, both here and also here. For number 7, we again have a problem where we don't need to do any factoring to find the LCD. The LCD just has both of these completely different denominators, so 5D plus 4 and 2D minus 3. And then we'll just multiply each of them by whichever denominator they were missing. So first fraction will multiply by the 2d minus 3 over itself. For the second fraction, let me make this a plus -1 to start off with here, and then I'll multiply it by the 5d plus 4 over itself. Multiplying these out now, for my first numerator, distributing that 8, I've got 16d minus 24 over the LCD, which has 5d plus 4 and 2d minus 3. Next fraction, I'm just distributing a -1 up there, so negative 5d minus 4 all over the LCD. Now I can combine these, so I get my LCD of 5d plus 4, 2d minus 3 in the denominator. For the numerator, 16d plus negative 5d, that's 11d, and then negative 24 plus negative 4 is negative 28. 11 and 28, there's no common factors there, so this is done. And I see this answer down here with choice B, so I'm putting that in box 7. All right, on to the next here. Another problem where there's no factoring to be done at the beginning. My LCD is going to have 4d minus 1, and now my other denominator of d plus 5's got to be in there as well. So multiplying these each by whatever they're missing. First fraction was missing the d plus 5, so multiply by that over itself. Second fraction, I'm going to make this a plus -7 up there. And now I'll also multiply this by 4d minus 1. That was the piece of the LCD that this one was missing. Distributing some things out. My first fraction's a little intense in the numerator. This is our first time that we have a 2 by 2 multiplication, at least in this problem set. So I'll just FOIL that out. So first is d squared plus 5d plus 2d, and then the last gives me plus 10, all over the LCD, 4d minus 1, d plus 5. On the next one, I can distribute this -7. That's negative 28d, and then negative times a negative is a positive 7 there, over the LCD. So when the dust settles, I have my common fact, my common denominator there. In the numerator now, we've got the d squared. 5d plus 2d is 7d, and 7d plus negative 28d is negative 21d. And then the 10 plus the positive 7 is 17. Doing a quick check here, are there two things that multiply to 17 and add up to negative 21? Nope, only option is 1 and 17, and that doesn't work. So this is done. Can't be factored and reduced. That's going to be choice N, so that goes in spot 8 right here, and also another one hiding at the end here. For number 9, they've upped the ante a little bit. You'll notice this first denominator can be factored a little bit, so I can take a d out of those. That leaves me with a d minus 2. Second denominator can't be factored. However, we can make this a plus fraction here. So I'll make this plus, and I'll distribute the negative to the numerator. So now I have a negative d plus 4 up there. Taking a look at my denominators for the LCD, we definitely need a d and a d minus 2. And that also covers this d in the second denominator. So changing things up to get the LCD, first fraction already has it, so no changes needed there. Second fraction, we're missing that d minus 2 piece, so let's multiply by that over itself. And I'll put this negative d plus 4 in a parentheses just to remind myself that I now need to FOIL out that numerator. So first fraction, still good the way it is. FOILing in my numerator now, we've got negative d times d is negative d squared, and then we'll have a positive 2d for the outers. Inners is a positive 4d. Lasts is a negative 8. All that over the LCD of d minus 2. Combining like terms and keeping my denominator the same now. In the numerator, d squared plus negative d squared is actually going to cancel, so that's pretty nice. We have 2d and 4d is going to be 6d, and then 3 plus negative 8 gives us negative 5. Can't really factor 6d minus 5, so that's done. And I see that right here, choice R, so that's going in spot 9. And we are finally on to the last problem. So here it is, final battle, number 10. And you'll notice this gets used not once, not twice, but 3 times. So they're going to pull out all the stops in this one. starting with making you factor this lower left denominator. So we have factors of 12 that add up to -7. 1 and 12 won't work, neither will 2 and 6. 3 and 4 does though. -3, -4. So both negatives, d minus 3, d minus 4. And then the next fraction, although I don't need to factor it, I would like to make that a positive so I don't have to worry about distributing negatives later. So let's make that a plus fraction, and I'll distribute this negative to the d and the 1, so -d minus 1 up there. Looking at my denominators, definitely need a d minus 3 and a d minus 4 for that first one, and the d minus 4 in the second one is already covered by this d minus 4, so we're good to go on the LCD. Rewriting things with the LCD now, first fraction is already good the way it is. For the next fraction, we need the d minus 3, so that's multiplying that by d minus 3 over itself. Going back, first fraction, still good the way it is, but now this next one I have to FOIL this out in the numerator. So we have -d squared plus 3d minus 1d plus 3, all over my LCD of d minus 3, d minus 4. Time to combine things now and keep the LCD that I found. So the d squareds are going to cancel. 3d minus d is going to be 2d, and -11 plus 3 is -8. Doing a quick check, it looks like I can factor a little bit in the numerator if I take out a 2. So let's keep the LCD for now and then take out a 2 up there. That leaves me with a d minus 4. Well, look at that. I can cancel my d minus 4s. So at the end of this one, we're just left with a 2 over d minus 3. And I see that right up here. This is an s. So we have an s here, and here, and here. Now that we've filled in all the letters, let's see if we can solve this thing. So why isn't a snowman very smart? So first word looks like a he, and then H-A-S, has. Snow seems kind of obvious because it's a snowman. And then this last one, brains. Why isn't he very smart, or she? He has snow brains. Another way, if you say it, he has no brains, is another way I guess you could say that. So I get that. It's a play on words there. Very nice. Perhaps a snowman came up with this puzzle. I don't know. Till next time, Mr. Sutton signing off.